Hello, everybody. My name is Tadas. I'm the System Analyst Programmer at DFnet Research, and I will be the one presenting controlled randomization and in-depth training on how to plug in the system into your DFdiscover study. Everyone is muted by default at the moment, and if you have any questions, please put them in the chat window on the side, and I'll be taking a look at them and answering any questions at the end of the presentation. We have a lot to get through today. Without further ado, I will begin. Controlled randomization. We will be first doing a quick review about the system and how it works, what you need to get started, so the ingredients, implementation, how to get this all put together, how to test it, and a quick little look at behind the scenes of what really makes us tick and the development process of this system. So let's begin with the quick review. How does it work? The randomization flows with someone completing a randomization CRF, confirming that the subject is eligible for randomization. It then prompts the user to confirm that they want to proceed with the randomization, and if they want to proceed, it will notify the user to save off the record, and it randomizes the subject. For the user, it's a pretty straightforward flow. An example of a randomization plate is as follows, and this can vary study from study. You can decide what goes up in your questions. It'll boil down to what happens in your study protocol. The general important bits are the bottom half where the randomization number is, the prompt for manual randomization, and the fields below that indicate the username of who signed it, the randomization date and time. The other important plate is the admin sequencer. So this is a plate that holds information of exactly how many people have been randomized in every single randomization table. So if you are randomizing people to different values depending on their gender or their age or what site they're from, this form is the one that tracks how many people have been randomized in each site or cohort. The mechanism map is, as previously shown, the randomization plate. It has an edit check called randomization on there that randomizes the participant, and the process that it goes through is it checks if someone is eligible. If they're not eligible, the user gets bounced back to the randomization plate. If they are eligible, the edit check then goes to the admin sequencer plate, and it will give that sequence value to the edit check, which then looks it up in a lookup table, and that lookup table brings it back to the edit check, and then that information gets plugged into the admin sequencer and the randomization plate, so the next randomization can be ready. If you want further and more detailed information about this mechanism flow, 2 weeks ago I did a webinar that provided a brief introduction to this, and at the end of this training I can showcase where you can find that recording. So the complete mechanism map flows pretty much two plates working together alongside an edit check and lookup tables. And it's just important that the users have permissions to both the randomization plate and the admin sequencer plate. With that being a brief overview of what was covered 2 weeks ago, let's dive into exactly what we'll need to create this system. First thing is the software. You're going to need DFdiscover. That's the first component. The next components are the randomization plate, the admin sequencer plate, edit checks, and lookup tables. So these four components together will ensure that the system runs smoothly. And for the case of this demo, I already have the randomization plate and the admin sequencer plate inside of the study with no edit checks applied or anything, but I do have over here a randomization plate set up and a admin sequencer plate set up. This is something that you can do just like you set up any plate for a study and I will be going into exactly what should be on each plate. So the first part is the randomization plate. This plate has an essential 7 fields: the visit number and the subject ID, which are key fields, and then the 5 randomization fields. So you have a randomization number, which is the number the user gets randomized to, checkbox that toggles the manual randomization, so allowing users to manually provide a date and time of randomization, the randomization username field, the randomization date field, and the randomization time field. So if I were to look into my study here, I have my visit code field, I have my subject ID, I have my randomization number field, manual randomization toggle checkbox, the username field, a date field, and a time field. So I'm all set. As long as you have those fields, you'll be able to plug in the rest of the components into your study. Next, we are going to move on to the admin sequencer. So the first piece of the admin sequencer is the visit number, which is also essential to any plate, and the subject ID as well. And then the only other important field on here is the sequence field. So these will be those fields that track exactly how many people have been randomized in each lookup table. So you can create this as a regular plate with an actual background preset, or you can create an ECRF. That is another benefit of DFdiscover. You can easily create an ECRF and then just plug in some fields. So here I have the visit number, the subject ID, and then 4 sequence fields that will track how many randomizations happened in each site, how many people were randomized in site 250, 350, 450, and our testing site 999. So the number of sequence fields you have will boil down to your study exactly how many lookup tables you're tracking. So if you are tracking something by gender, then you'll probably only have 2 sequence fields. If you're tracking by age groups, you'll have as many sequence fields as you do have age groups. So you get to decide, and that flexibility is there for you. So edit checks. You can download the randomization edit check file, download the view only and hide me edit check files, and download the DF Open Patient Finder edit check code. So these snippets of code are available all on Medusa. You should have received now an email from labkey@dfnetresearch.com, which provides you login credentials to our website, Medusa, and over here you can see information about the randomization unit. So you can go in and look at the general overview. So if you missed the training or webinar that happened 2 weeks ago, you can go over here and see a recording of the previous webinar and download any documentation, see an FAQ section, and contact information. You can also see this new section for an in-depth training where if you enter in, you have access to the PDF of these slides. So if you want to be following along or review it at your own time, it's available here. The online training recording of this training here will be coming soon and will be posted here. And then we have the code. So over here we have code for each section. So if you want to, you can show and hide the code here, or you can download the direct file that has all this information. If you don't want to copy paste this into your system and you'd rather download the file and plug it in on the server on the back end, you can go ahead and do that. The options are here, and so this is where you can download the code. Lookup tables. Gather your lookup tables. These are the randomization lists that are going to be used. Important things to remember when you have your lookup table set up is that yours only has 2 columns of data, the sequence value and a randomization value, and they're split by a pipe. All sequence values are identical in character length. I will be showcasing an example of that in the next slide. and all randomization values must be unique and no blank spaces. If you do not have your lookup tables available yet, you can download a sample from Medusa. So this website also has a little section here where you can download a sample of a lookup table. So I just download a sample. You can open up these files and copy their contents into your study. Randomization list. So its basic format is a sequence and pipe delimited to a randomization value. So a good example of this is the sequence value on the left. It's numerically chronological, and each randomization value is unique. A bad example is not putting zeros in front of the sequence values. They aren't all identical in character length. The first 9 instances are 1 character long, but the next few are 2 characters long. The system needs a consistent pattern of how many characters is inside the sequence on the left. And it's pretty visible here that the pipeline on the bottom 2 is offset from the others. A reminder that what we put into the database is the blinded lookup table. So it's something that doesn't actually have the treatment options associated with each sequence value. And the pharmacist or whomever is unblinded will be getting the same table with just the treatment value as an added third column. So if you actually have an unblinded study that you're using the system for, you can actually have a third column, but you will need to adjust the code slightly to recognize that and to split off the treatment. Implementation, putting the puzzle together. Importing the lookup tables is the first step. Then we want to import the edit checks into the study. We'll be applying the edit checks to the fields, setting up user permissions, and finally customization/adjustment. So that last component is what's going to let it really fit well in your study and make it your own code. First thing is lookup tables. Import your lookup tables. Let me go and download these. There we go. So this is an example lookup table. So I can go in to my study, go to lookup tables, and I'll add a new lookup table and call it random 250 because this is a randomization list for site 250. I'll put in those values, and again, note that these are 3 characters long, even though I could have had all of these be 2 characters long, but seeing as I didn't know how many sequences I'm going to be adding, I'd rather just play it safe and have a 3-digit value on the left-hand side. And then on the right-hand side is the randomization number that will be associated with each sequence number. I'm going to quickly open up these remaining 2 lookup tables and put them into the study. And so these lookup tables, please do not use the ones here that I provided in your official study. These are samples of showcasing what they should look like. Your lookup table should be uniquely defined and created for your study by some sort of data analytics team. So I'm going to add in this final lookup table to showcase the process. And we have now added the lookup tables to the system. Now that that's done, the next step that we need to do is map the lookup tables. Inside of the lookup tables map, we want to associate a term with each lookup table so our edit check can use it. On the left-hand side, this is what the edit check will be referring to. On the right-hand side, this is the name of the actual file. So just For simplicity's sake, I'm going to call them both the exact same thing. The table name is on the left and the file name is on the right. They're both the exact same term, so it's less confusing. They don't have to be the same. As an example over here, the table name is called QC, so if in an edit check I call for a lookup table called QC, it will find the df_QC query.lut file. But I find it cleaner to just have the file name and the table name, if possible, to match. Now that we have the lookup tables implemented, a reminder about the naming. Now that we have the lookup tables in there, we are going to tackle the edit checks. So we're going to add the view-only code into our DFEdits files. Now I'm going to open up my edit check window, and inside of my edit check window, I can scroll all the way to the bottom where there's no other edit checks, and I will copy over this view-only code. Now I've added it over here, and just to double check, I'll check syntax. Great, no errors. I provided good code. Then next is the hide me code, which also you can grab from here and just plug it into your study. And now we have just added the functions that will make certain fields view only and hidden from users. This is primarily for security and ensuring that people don't tamper with fields that they shouldn't be touching. So now part 2 is adding the randomization code. This is the core of the entire system. You have two options. You can either copy paste directly into your DFEdits file, or what I would recommend is creating a new edit check file and call it randomization. Inside of your edit check window here, you can press add in the bottom left and then create a file called randomization. Once I create that, I can go and grab the code from inside this randomization block. If you want, you can also just download the file and plug it into the server on the back end if you have access, and that will achieve the exact same thing. So now once I've added this, we need to remember to #include it. So this way it reads the randomization edit check file. We check syntax, 0 errors, 0 warnings. So now this way we have all of our randomization related code in its own file, and it will not get mixed up within all the other edit checks inside of your study. And then part 3 is the final part, which is update your DFopen patient binder edit check. This is what prevents site users and people who shouldn't be reaching the admin sequencer from actually reaching the admin sequencer. If you already have a DFopen patient binder edit check, just copy paste the code that's inside of the snippet that I have provided. If you don't have the binder edit check, then just copy paste the entire thing. If I go to the code here for DFopen patient binder, if I already had this edit check inside of my study, I would just copy the contents inside and add it alongside the other code. But since this study doesn't have DFopen patient binder yet set up, I am going to go and add it. So inside of my DFEdits file, I'm going to go here to an open area and add this code. So this code is what ensures that users will appropriately hide and show the admin sequencer depending on role. You can adjust this as appropriate for your study. For my study here, it's set up that at site 888, that's where the admin sequencer is going to live. If you are not an administrator and you're not a data manager, then hide everything. So that means if someone tries to open up site 888 and they try and open up the admin sequencer participant binder, it's going to show as if they have no records And if they are an administrator or a data manager, then it's going to hide everything except for the admin sequencer. So administrators and managers can look at that sequence plate and see where things are. Yeah, adjust as appropriate for your study. Applying edit checks. So now that we've actually plugged in all the lookup tables and the edit checks have been plugged into the study itself, now it's time to apply them to the plates. I'm going to drag this on the side here so I can see both windows at the same time. I'm here on the randomization form. So the very first thing is the random field, which is the randomization number. For plate enter, I want to add view only. This will make that field view only so people can't type in some alternative number or manually enter in something that is incorrect. For field entry, we want to add ready to rand queue. So this is a prompt that tells the user or asks the user if they're ready to proceed with randomization. And for plate exit, we want randomize. This is the actual edit check that will randomize the participant. The next step is the manual randomization field. For field exit, we want to add rando manual. This is a edit check that opens up the ability to adjust the randomization date and time for cases of manual randomization. And then for these final three, for the username, ran date, and ran time, we want to just make it view only. So for plate entry, I'm going to add the view only edit check, and we should be good to go. Now we're going to apply the edit checks to the admin sequencer plate. We're getting really close to getting this up and running. I'm going to go to the admin sequencer. And over here, I have the visit num, which needs to have the hide me edit check. This isn't essential, but it helps make the form really clean to ensure that when you're looking on an eCRF and there's a bunch of sequence fields, you don't mistake the visit number or the participant ID or subject ID for a sequence. So I just hide the key fields. And then for every single one of these sequence fields, which in my study, I call them RAN 250, RAN 350. You can name them what is appropriate for your study, but these need two edit checks. Update value, which increments its value by a single digit if the randomization happens, and view only. So if someone like an administrator is on the form, they can see it, but they can't manipulate the data on it on accident. If you really need to alter the data for whatever reason as an admin, if something is misrandomized and it's okay for your protocol to undo the randomization. So if someone accidentally randomized something without actually injecting a participant with the treatment, then it's possible to just turn off edit checks for that field and then bypass that. But I don't know whether that is okay with your study protocol, so you'd have to confirm that. But the availability is there just in case. Now that we have these edit checks applied to the fields, we are going to look at user permissions. Anyone who has access to the randomization will need, they will need this line of code located on the second row. This is what indicates that the user can write to the admin sequencer plate. So the admin sequencer in my example here is a plate called admin sequencer located at level 6. It is plate 499, visit 999. And the user has the ability to create and modify data on here, but all edit checks will prevent them from actually reaching the plate and doing anything. This will in turn allow only the edit checks of the randomization unit to manipulate it. But this is mandatory because you need the edit checks to be able to go over to this plate and update the value. The new line grants this role write access to the admin sequencer. So you can take the same user role that you already had previously set for a site data entry user and just add this component. And then the second step for user permissions is each user who will be randomizing needs access to the administrative site. In this example here, I have access to both site 250 and site 888, which is the site where the admin sequencer is going to live. The next bit is the customization. And this is the funnest part because you get to make it work as you want it for your studies. There's a total of 7 edit checks that we have added into the system, and we will be able to customize 4 of them. Update value, view only, and hide me are not customizable. The top 4, random ready, ready to ran queue, randomize, and random manual, each have certain components that you can randomize to make it feel the most appropriate for your own study. Customization inside these edit checks works by just altering some variable values in between a segment called customization and before the section called functionality. So if I were to look inside my edit checks and I go to my randomization file, over here you can see that there's a section for customization and a section for functionality. Any section that's in between, you can customize that. That will change the behavior of the edit check. An example here is ready to ran queue. Its actual function and what it does is built down here, and you don't have to worry about it. You don't need a lot of coding experience. You don't really need to know what's going on. You don't have to deal with that piece of code. What's important to you is these 3 pieces over here where you can decide, well, what is the question I'm going to be asking the user? What is the prompt that I'm going to tell the user if there was an error and they're unable to randomize? And what am I going to notify the user to do if the subject is eligible for randomization? You customize those bits and make the system work to your liking. The first thing we're going to look at is random ready. So this function it's a function. It's not an edit check. It is a piece of code that is used by other edit checks, and it is used by ready to ran queue and randomize. It is a function that either returns a 1 or a 0. It returns a 1, indicating that the subject is eligible, or it returns a 0, indicating that the subject is ineligible. So what you get to customize is, well, what are the conditions to return a 1? The code of random ready has that customization section where you can put in all the conditions of what is required to return 1. So do you want a condition to check that they have submitted a inclusion and exclusion criteria forms? Do you want the condition to be that they are within a specific age range? In the case of this example, the customization is if these 3 fields have been marked the value 1, and if they are, it proves that they are eligible, and thus it will return a 1. Otherwise, if those are not true, the code is going to reach the bottom, which returns a 0. So if all conditions to return a 1 fail, return a 0. Over here in the code that I provided online, it's just a if field 9 equals 1, you'll adjust this to what is appropriate for your study and ensuring that it's pointing to something correct. So in my case, if I look at the study and I go to the randomization plate, it's checking that I said yes to item 1, and that's what considers the participant eligible. So the next piece is the ready to ran queue. This is the question that gets prompted to the user asking if they would like to proceed. This uses the random ready function that we just covered to confirm eligibility. So before asking the user if they want to proceed, it will use that function and confirm that they are actually eligible to proceed. You get to decide what question is asked to the user, what error dialog appears if the user says no or isn't eligible, and what dialog appears if the user says yes and is eligible. Again, those 3 variables between the customization and functionality alter what their value is, and it will change the behavior. And I'm actually going to go and do that real quick here. I'll update this random ready to be a condition of if at 9 equals 1, if at 10 equals 1, and at 11 equals 1. So I want to make sure that if they said yes to all items 1 through 3, that considers them eligible. And then for these ready to ran queue variables, I think this language fits perfectly for my study, so I'm not going to even bother altering it. Third component is the random manual edit check. So this one makes the date and time fields editable. Your customization is just pointing which field number is the ran date, which one is the ran time. As you can see that the ran date and ran time are the only two lines of code that exist in the customization section, and you just have to make sure they're pointing to the date and time fields. In my case, the date field is 15, the time field is 16. So let's check that this works. So random manual, yes, the customization is pointing to 15 and 16. This will probably be a different value in your own study. This just ensures that it's unlocking the correct fields. And then the final piece, which is the most advanced one, is the actual randomization edit check. So this randomizes the subject. It uses random ready, which we customize to confirm eligibility. And its customization goes into a lot of categories, and we're going to cover each one of these. Study details, you can specify the name, development number, production number, which point to the right field. So what are the field numbers for the randomization number, the username field, the date field, the time field? Where is the admin sequencer located? So specifications about the subject ID, visit, plate, level. Lookup table specs, so adding a sequence length, max sequence values, how many characters each sequence is, and how many sequences do you have per lookup table. The case, this will point to reference fields and table names. So using this code, you'll be able to customize which table to utilize under what conditions. Emailing, what subject to use, who to send it to for official live databases, who to send to during testing, and who to notify in case of errors. Error warnings, if there's an issue with the lookup tables or user permissions, what gets presented to the user, and error emails, if there's issues with the lookup tables or permissions, what gets sent to the error alias. So let's dive right into it. Study details. I'm going to just open up the code so it's a little more visible. If you go and find Edit Randomize, and then you just scroll down to the customization section. You don't have to worry about the code above, and you don't have to worry about the code below functionality. It will do its own things there. But for the customization section here, it's just a list of values again. There's settings. For study specifications, you have the study names. I'll call this Sandbox Tadas Demo. Study development number. I think this is study 979, and since I don't have a production number, I'm going to just use 979 as well. If we look back at the presentation, I have information here about every single one of these components. If you want a short description of what each one of these does, you can reference this. The next piece is the randomization fields. You have to point to the 4 randomization field values. In my case over here, this is pointing to randomization number is field 12. The username field is 14, the date field is 15, and the time is 16. If we confirm that, we have the number at 12, username at 14, date at 15, randomization time 16. For you, you'll have to probably alter that number slightly. Next component is the admin sequencer specs. The subject ID of the administrator, plate, the visit code, the plate number, and the level at which you want it to live. In my case over here, the ID is 888-888. It's at visit 999. The plate number is 499, and I'm going to be saving it off at level 6. I have allocated level 6 to being specifically for administrative purposes. This way, we don't accidentally running batch or other systems push the record outside of view of users, and we know exactly where it will be and what level it will stay. You don't have to use 6. You can always change how this works for your study, but I would highly recommend that you pick a location where you know it's secure and no automated system will accidentally move the record. The next component is the lookup table specs. So this is the sequence length, character length of the sequence values. So inside of my study here, if I look at my lookup tables, each sequence is 3 characters long. It's the value on the left, not the randomization number length on the right, but the sequence value on the left. This way the system knows how many zeros to anticipate in the front of your numbers. So if you have a single digit value, to anticipate 2 buffering zeros. And then the last part is the sequence max. This is how many entries do you have in this table. This number helps the system recognize if suddenly you try and randomize a 22nd person, that there isn't a randomization value available for this. You can more appropriately adjust and have an error that explains, hey, you reached the end of the lookup table. Case, this is the core component that's going to make your customization really your own. So this is what conditions decide which field and table to reference. If you are referencing 2 different lookup tables, depending on the sex of the participant, then you're going to need to use this to check for the gender of the participant and then load in a different table and reference field based on that information. The important parts are that you have a case, which is your condition, a reference field, which is a field number, points to the correct sequence value that you're looking on the admin sequencers. If you're referencing a lookup table that is being tracked by field 9, your ref field would be 9. Then you have the lookup table name, which is just the name of the lookup table to use. The system asks, in which case does the system use which sequence on the admin sequencer, and which lookup table should it reference? First, you assign a condition case to the variable case, and then you look at different reference fields and table names based off of that. The first part is assigning the case. So case is DF center at 7. I grab the site value. So I figure out which site am I from. Am I from 250, 350, 450? Am I the test site 999? Then the next component is just saying, well, okay, if the case is 250, then the field I'll be referencing on the admin sequencer is field 8, and the table name is 250. It knows not to use table name random 340 or random 999 if I'm in site 250. And then in the next entry here, if case equals 350, reference field 9. So I don't want to be referencing the exact same sequence tracker. I want to make sure that I have multiple sequence fields inside of my admin sequencer that is tracking how many people have been randomized in each case. A more simple and probably more common example would be this case by sex. If you wanted to have your lookup tables, have one lookup table for female participants and one for male participants, you have your case first establish the sex of the participant, and then it will check if the sex that they discovered is the value of 1. If they're a female, then reference field 8 and use the randomization female table. If they are a male, then reference field 9 and use the male randomization table. That is where you're going to get most flexible with, and you will have your conditions. If you want to do age groups, if you want to do cohorts, if you want to do month-based or date-based, you have all the options there. We're approaching now the end of the customization, and so we have just segments of what emailing information gets sent out. If I look back at the code, I have here the case set up, and that's appropriate for my study, and over here emailing. So what subject gets sent in the email? So if someone does get randomized, what email gets sent out? This is the official list of who gets the emailing notification, and if someone were to press reply to that email, who would it get reply to? I'm going to put my email in here temporarily. just to showcase this demo. Then over here is the testing email list. So if you are testing this out and you're in the development study, who's it going to email? In this case, I'm going to email myself as well. But normally the person who's developing this would put their email in here, while the production list would actually have maybe the pharmacist or site users who are interested in knowing when someone is randomized. And the final section of emails here is who gets the error notification. So if something goes wrong, who gets notified? Again, I'm going to put myself in there. And then if I have an error, what warnings do the users see and what email content gets sent? To the user, they don't really necessarily care about who they are or what subject ID failed or this information about exactly what on the setup might be wrong. So for them, you might have some generic message over here like error failed to find a randomization value. Please contact the study data manager. You can customize these and adjust them. These are the different errors for the different cases that could go wrong. So either a lookup table is missing, or an invalid sequence ID is trying to be found, or if someone doesn't have permissions to the admin sequencer. Same thing over here with the emails, what actually gets sent to the error alias. So the person over here in this section will get these error messages if something goes wrong. So then the user can be instantly notified about anything. Adjust those accordingly. They're good here for my case. And a few optional cleanups you can do to make it just work a little nicer is add the admin sequencer visit code to the visit map, because right now, since it's not in there, it's just an unexpected record, but you can adjust that accordingly for your study and change the level 6 label to administrative or something that makes more sense. And again, if you aren't actually using level 6 for admin sequencer, you don't need to change your level label. If you go into global settings and you go to levels here, you can change this to administrative. That way then inside of the database, people know that level 6 is administrative only. You now have added the lookup tables, implemented the edit checks, and customized the code to fit for your study. Now that you've done that, we get on to the fun part of testing, ensuring that it works. To test it, you would have to log in as someone who has permissions to randomize. I already set this up for myself for the case of the demo. So I have a testing site entry user account, and I will log in. And if I go to my sandbox study, I am now a site entry person. And you'll notice that if I try and open up any participant in administrative, it won't load up. It'll try to, but it will just hide everything. So that's great. We know that the user can't accidentally go in there. So if we now go to the randomization form, and let's say I try and randomize right now by saving, it says the subject is not ready to randomize. Please ensure they are eligible for randomization before proceeding. You can't save the record off as incomplete. And so now that they are eligible, if I try and still save as incomplete, it will say that this CRF must be saved as final to proceed with randomization. Please save as final. Again, you can alter that language during the customization. But now if I enter the randomization field, prompt will be here to ask if I want to proceed with randomization. If I say yes, it will indicate for me to mark this form as final to randomize. When I hit final, it will just confirm you're saving this record and this will randomize the subject. Proceed, yes, no. If you say yes, the subject has been randomized to 595. Please print a copy of the form and put it in the subject binder. If we go back to this randomization form, we can see that the username, who randomized was plugged in, the date, the time, the randomization number. And if I go to administrative, I still can't reach the admin sequencer. But now I'm going to quickly hop out and go in as an administrator. As my main account, I have administrative permissions to this study. When I go in and go to the administrative site, I will be able to see this admin sequencer, which will say that one person has been randomized for site 250. Yeah, this testing process just showcases what you can do, and I'm not going to go through all the tests here. Just kind of going briefly over the concept that here you want to test that you can randomize. You can confirm this randomization continues to work by randomizing another subject. It proves that the admin sequencer is updating as anticipated. It's a good idea to randomize multiple subjects to ensure that the code is truly randomizing someone to a new value every time. It also confirms that the user had permissions to even reach the admin sequencer plate. You can log in as the administrator and check the admin sequencer, so that's what we just did now, and we can see that the sequence value is what is expected. Since we randomized a single individual in site 250, we have a sequence value of 1. You can also look in DF setup the lookup tables and confirm that the appropriate value was randomized. Again, if I look at my lookup tables and I go to random 250, you'll see that sequence number 001 is associated with randomization number 595. And if I go to this last person that we randomized, they were assigned the value 595. So it is working as anticipated. And check your email for notice of randomization. I don't have my email up right now, but I should have received a testing notice, since this is my development study, quote unquote, to confirm that it worked. And so you want to repeat this for every case you have. So if you are doing 2 randomization lists, like one for female subjects, one for male subjects, go through all those tests for each one individually to ensure that each case is appropriately set up. If you have 4 cases, do 4 different tests for the 4 different tables. Testing ineligibility, log in and try and save the plate as incomplete. We did that. It didn't let us save it. Try and save the randomization plate when the subject does not pass the eligibility test. So make sure that the conditions for random ready are false and try and randomize. It should fail. Test security. So this is ensuring that people can't manipulate data. Try and edit the randomization number, username, date, and time of those fields. You shouldn't be able to edit any of those. So if I'm inside of here, I cannot type and override any of the values here. So they are hard-coded to ensure that people don't alter things. Try and open up the admin sequencer as the user. So again, if we try and go to the administrative section and I try and open it up, I'm logged in as myself, not as the site entry user, but that should not be visible. As the admin, I can see that form. And then as the administrative security, you should ensure that you can find the admin sequencer. It's only visible if someone has randomized, because the randomization unit will create that plate if it doesn't exist. And on the admin sequencer, you should double check that the subject ID and visit number are not visible, that all other fields are visible, so the sequence trackers are visible but not editable, and you can test the manual randomizations. Log in with someone who has permissions to randomize, complete the randomization plate, and if you mark that manual randomization box, you will notice that you'll be able to suddenly alter the date and time of randomization. Thus, if a manual randomization occurred 3 hours ago and you're just inputting the data into the database, you can input that previous date and time, and when you randomize, it will not override your values. And randomization successfully occurs. So now just really quick, about to hop into a few components as we wrap up here. Behind the scenes functionality. So we're about to get a bit nerdy. What are the 3 components that make it work? One of them is utilizing global variables. This is something I don't see a lot of, and it is super powerful. So we have the edit check use a global variable called ref field over here that gets established, and inside of the randomization unit, when it confirms that someone is eligible, it will update the ref field value, and then when you go to update value, it can check whether that global variable matches the field number that we're looking for. This will allow you to be able to make both plates communicate. Using global edit check or global variables to communicate between edit checks is super powerful. Cross-subject DF triggers. So this is a new feature in DFdiscover. This is why this requires DFdiscover. You are not allowed to use DF trigger to manipulate data on a different record on a different participant ID. In previous versions of DataFacts and DFdiscover, you can do this. And so that's what allows us to, upon randomization, have the system update the admin sequencer that's located on a completely different ID that everyone can access. And the third part is flexibility. I keep as minimal code in exact values. And when you stop thinking about exact values, you begin to see the big picture. You no longer design for the value, you design for the concept. So with this edit check, it's designed to be flexible. It's designed to be able to do a lot of things and to be able to grow and expand. And you don't really need much coding experience. You just need to be able to change those variable values. The system will adapt and learn how to work with you. If you do take a look into the code, it is set up in a way so you can keep expanding it. So if you have coding experience, I highly recommend you try and rip apart this code and upgrade it, make it better, add more toggles, add more flexibility. Finally, development behind the scenes. This code didn't accidentally make itself. As much as I wish it did, it took many, many months of development. So it actually began development in summer of 2018. It was 61 lines long. It was a single edit check. It had no error checking or reporting. So if something went wrong, it went wrong and no one knew. It didn't send emails nor record username, date, time. It could only utilize one lookup table. It didn't even use an admin sequencer. What it did instead was it looped through every single subject in the entire study to find what sequence values were used and which ones were not, which is super resource intensive. And for people with poor internet connection, it crashed a lot. Kept updating it, and in fall of 2018, we got to version 2.0. It doubled in the lines of length. We split it into 6 edit checks. We got a little excited, and 2 functions. The idea of the admin sequencer was adopted. It was known as the random tracker plate back then, and it began to send emails, which was great. But it sent too many emails because there was no differentiation in aliases. So the people on the official emailing list got every single email, even the testing ones, and they looked real. So it was difficult to test, but luckily we have upgraded since then. Winter 2018, we got version 3.0, 137 lines long. It's not that, DFXplorer. It's not that much more fancy, but we did compact it a little more with not being 6 edit checks and 2 functions. So we decreased it. We added more flexibility so it can do multiple cases. In this case, we had 3 different cohorts, and it allowed some error checking and emailings. If something went wrong, I was notified immediately, and the official distribution list now no longer had to be bothered every few minutes as we were testing things. And we added manual randomization, which is great. That has a lot of the core components. And then finally here, with today's unveiling, we have a edit check that is 314 lines long. It is very flexible and customizable. Previous ones, you weren't allowed to customize things, really. It was all hard-coded. It has more error checking. It ensures that if a value is missing, a lookup table is missing, permissions aren't set up, it appropriately emails the right person with the right information. It has its own training and documentation, and it's being used by multiple clients now. It's never been so easy and yet complicated to randomize with DFdiscover. So for more information, you can go to medusa.dfnetresearch.com. Everyone here should have received access to it. It has the online trainings. It has recordings of webinars and online trainings. So if you missed the first part, you can watch that. It has documentation. This recording will be up on the website as well. Code to the direct components is there, and more. If you have any questions about Medusa, you can contact our IT support alias here. If you have any questions directly for me, you can contact me at tadas@dfnetresearch.com, but I've kept in contact with all of you with individual emails and invitations. Thank you very much and have a wonderful day.